Hello class. I'd like to go over what's called the t-test. Very similar to the z-test. However, a lot of times we don't have the population size to conduct a z-test. And a lot of times when we don't have a known standard deviation variance, we're forced to use a t-test. Usually we do a t-test when we're comparing the means of two samples. And the two samples can be independent or they can be dependent. It can be the same group of people that we're comparing, maybe like an intervention to one group, and then I test them again and I look at the mean differences between those two groups. But what I want you to do for this homework that we're going to do, we're going to look at an independent samples t-test. And what that is the two samples are independent of each other. And what I've done is I've taken data from a statistics class that I taught, the final test exam, and then class 2 is a totally separate class, but I've supplemented video instruction, so that's going to be my independent variable is the video instruction, and my dependent variable is going to be the outcome or the measured test scores. So I've got these two independent samples, and now I'm going to compare the means, and I'm going to show you how to do this in Excel because it's really going to make your life a lot easier. So I'm going to use this particular test statistic. T is going to be equal to the mean of group 1, class 1, minus the mean of class 2. Now I'm going to divide that by taking the square root of the variance for sample 1 plus the variance for sample 2 over the number of observations in sample 1 and over the number of observations in sample 2. Now I need to know what my degrees of freedom are. So degrees of freedom is going to be equal to 2n minus 2. So basically that's taking both samples, adding the two n's up, which is 20. I've got 10 in each sample. And so I have equal variances now. So now I've got 2n minus 20 is going to be equal to 18. So 18 is my degrees of freedom, which is going to be important for me to when I go look up my critical region when I either reject or fail to reject the null hypothesis. Now my null hypothesis is going to be that there are no difference in means. So the mean of sample 1 is going to be equal to the mean of sample 2. Now what I'm hypothesizing is that my scores are going to be different. I'm going to say this is going to be higher than class 1 since I got a video instruction, and I think it will enhance their scores. So what I'm saying is the mean of sample 1 is going to be less than the mean of sample 2, and we will actually calculate that. So without further ado, I will show you how to do this in Excel. Very, very simple. So the first thing I'm going to do is I'm going to find my mean. So how do I do that? Well, I'm going to come over here. I've already typed in the mean, the standard deviation, the variance, the n, and the t-test. So I'm going to go ahead and calculate my mean. So I'm going to come into this box and I'm going to command Excel to find the mean. I'm going to go ahead and say equal average. Average. So it's going to be this one here, average, and then I'm going to go ahead and put some parentheses in there to give it some parameters, and then I'm going to highlight the data here, and then I'm going to close my parentheses, and I'm going to hit enter, and that should give me a mean of 74. So I've got my mean of x bar 1 is 74, and a real easy way to do 2 is just move over highlight that box, and when you get a plus sign, just move it, whoops, let me do that again. Just move it over, and it will calculate the mean for the second group, which is 87. So now I've got that. Very easy. Now I'm going to go to the standard deviation. So I'm going to type in a command equal STDEV, should do it. And that did highlight that. So I got a standard deviation, and now I'm going to give it some parameters again. So I'm going to highlight the data. There we go. And now I'm going to close that parameter. And I've got a standard deviation of 16.36392. Just take it after the second decimal place when we actually calculate this. And now I'm going to find my variance for my second, and I'm just going to drag that over like I did for the mean. And now I've got my variance for sample 2, which is 8.524, so just go with 8.52 would be fine. Now I'm going to find my variance. Since I've got my standard deviation, now all I have to do is go in, highlight this, and then I'm going to command it to square that particular function, and that should give me my variance. Let's see if it does. And it did, so good. I've got a variance of 267.77. So that's what I'm going to use. I'm going to go do my nifty little trick again up here, and I'm just going to drag that box over, and now I got a variance for class 2 or data set 2, which is 72.66. Now to find n, that's a pretty neat trick too. I'll just come over here and I will say command this thing equal count, and then I'm going to give a parameter. I'm going to go up and I'm going to highlight my data, and I'm going to close parameter, and I should get a value of 10. I did. Now I can drag that over and it will give me the same calculation. Once that turns to a plus, move it over, and wow, this is cool stuff. Now I'm going to find my t-test. And what the t-test is actually going to do is not going to give you a t-value, it's going to give you a p-value. Since we've talked about p-values already, the p-value is actually the probability of making a type 1 error. So I'm going to set my alpha level at 0.05. So alpha level is going to be equal to 0.05. So now, my p-value, once I calculate that with my t-test here, if it is less than 0.05, then I can go ahead and reject the null hypothesis, because the probability of making a type 1 error is going to be less than 0.05. So if I have an actual t value, it's going to be greater than my critical region value. When I look that up for 95% of the area under the normal curve, I'm looking for that t-value that has only 5% left. So let's find that t statistic and see what we come up with here. So I'm going to go ahead and command this thing to say equals t-test. And now it's looking for something here. So what is it looking for? Well, we'll find out. So it's looking for an array. So I'm going to give it an array of class 1. So I'm going to go up and highlight class 1. There we go. I'm going to put a comma, and then I'm going to get asking me for array 2. So I'm going to come over here and highlight array 2, and it gives me C1 through C11. I'm going to go ahead and put a comma there, and it's asking me for how many tails. Since I've given it direction, I'm going to ask for 1 tail. So I'm going to put a number 1, and then I'm going to go with a comma, and it's going to ask me for, is it a paired sample? It is not. It is a 2-sample of equal variance. It is actually a 2-sample equal variance. Since I've got equal n's, I can use a 2 independent sample t-test. So if I had 2 samples that are independent but they had unequal variance, then I would use number 3. But for my test, I'm going to use a number 2. So I come in, I use a number 2, and I close that bracket, and I should get a value, a t-test value. Now this, remember, is a p-value. It's going to give me the probability of making a type 1 error. Now I've got 0.019435. Do I fail to reject, or do I reject the null hypothesis? So since this test statistic is 0.019, it's actually less than 0.05. So since it's less than 0.05, there is less than a 0.05 chance that I'll make a type 1 error, so I can go ahead and reject the null hypothesis. If the p-value is lower than the alpha level, you can reject. Now, if this p-value is actually 0.07, then I would have to fail to reject the null hypothesis. Now I can say, based on this data, that there is statistical scientific evidence that class 2 that had the video supplementation has a significantly higher test score on their final exam than class 1. Now to actually calculate the actual value, I'll do that in another video.